Okay, hello everyone, and welcome to vBrownBag, the weekly IT video podcast where we bring some experts in the wide world of technology to talk about their favorite topics and also us. Kind of like a show tell for tech geeks like myself, or in this case, we have Aritra, to learn about something new. Today, this night in particular, we're going to talk about Opentelemetry. You can see the title, A Song of Decentralization and Observability. So we're going to talk about Opentelemetry. You will find it more with Aritra. So before starting, we a few housekeeping notes. You can get in the conversation. So this is live right now. It will be uploaded to YouTube later. But if you write something in the hashtag vBrownBag, I will be monitoring that one. So in case you want to make some questions, that's open. For our audience, you can also follow other accounts that we have. This is vBrownBag EMEA, because we run every Tuesday. We try at 7 p.m. BST, which is British Summer Time, which is 8 p.m. in Central European Time. And also there's another show, for example, tomorrow at 7:30 p.m. Central. You can find has the account for Aritra on Twitter, Aritra Nag 4, and myself, Dan Belmonte, as Dan Gaden. And enough of introductions. I think Aritra itself can just take the control and show us more about Opentelemetry, which I'm looking forward to it.
Nice. Thank you, Dan, for this warm welcome and inviting me for this show. So I'm really glad to present in front of the community, and I'm pretty much sure you will enjoy as well the topic that I have brought here. So to start off with my presentation, I'll be sharing my screen, and for some of the time I'll be checking out my console, where I'll be showing some of the snippets that I have brought across as part of this demo. Then I'll also probably showcase some of the slides, because it's of course good to have some visualization of the solution constructs and everything from time to time. And lastly, also, I will go into the AWS topic, because since the whole ecosystem or this whole infrastructure is deployed in AWS, we need to have a little bit of handshake, and I am planning to showcase that as well. So without further ado, let me start off by introducing myself. So who am I? So my name is Aritra, and I am basically from India, but I have been living in Sweden for the last 5 years, having around more than 12 years of experience in the industry. Started as a Java developer back in India, and then worked across multiple consulting companies and product companies. Right now, I am part of a consulting company based out of Stockholm called Playground Tech. And I am part of the cloud team, where I help customers mostly within the Nordic regions to ease out their AWS problems, along with migrating their workloads in AWS and other infrastructure related activities as well. That's my daytime job. But apart from the daytime, I am also an AWS ambassador and a community builder, which are some of the recognized tech communities that have been primarily based out of AWS, where I get to showcase some of the technical constructs and some of the technical challenges that I have tackled in the customer or the real life, as well as I write out some blogs, and I, of course, time to time present myself in different forums. And that's mostly it. And also, on my free time, I travel a lot. And as you could see, Dan, this is the picture from Ibiza. So I guess you can recognize this. It's one of the famous pictures in the island of Ibiza.
Really nice one. Yeah, it's Bedra. Yeah, I know.
Thank you so much. All right, moving on to the topic or the contents that I have planned to showcase in front of you. So first, I will start off with a little bit of PowerPoint presentation. Then where I'll tell what is observability, how Opentelemetry was born, and how the whole concept has started getting adopted within the cloud native ecosystem. And lastly, after doing showing some real life demos and code snippets, I'll try to conclude the session with some of the open tracing related or AWS open tracing, or I would say like tracing related implementations, and how AWS managed services called X-rays helps in that. And lastly, there will be the cost estimates that you can actually predict when you start using those construct, or let's say you try to build a holistical solution around this. And then I'll leave the room for some questions at the end of this. Perfect. Having said that, moving on to the first topic, what is observability? So back in let's say going back 5 to 10 years ago, when there was like big monolithic systems where there was like multiple teams guardrailing the enterprise solutions, consisting of support teams, first layer support, second layer supports. And I remember being part of those realm as well, where I was supporting the enterprise applications, like checking out those logs, going through thousands of files just to do a key point search of, okay, where the error has occurred, or let's say how the whole system has failed. And then writing a remediation steps on top of that, manually, like in notifying a couple of stakeholders, and then finally having downtime and resolving those issues. But those are like days of the past, I would say, and going and moving fast forward right now in the 2023, and probably in the next 4 or 5 years, you will see a huge, I would say, improvement in terms of this observability or setting up the support paradigm. So I would say back in 2021 or 2020, I'm not sure about the exact year, in one of the AWS big conference called AWS reInvent, they started using this term called observability and coming up with different managed services to tackle those things. Now, you would find loads of articles around the whole system and the whole constructs, but coming down to the few points, thing that I have highlighted here is this whole system works on mainly 3 signals. The first signal that you can see is on the is present on the screen. It's called matrix. I'll just, for the viewing sake, I'll just make it a little bit larger so it's easier to view. Yeah. Yeah. So first, matrix is one of the first signals that is finalized, and that has been coming up in the observability systems, and that helps us to detect if how the whole workloads is running. So let's say you have deployed a application, front-end application, or a web server in EC2. So what you would do is, like, you would monitor some of the things like their CPU bandwidth, or number of requests, or their memory utilizations, or let's say if it's a EC2 instance store, what is the IOPS that is happening, or let's say if it's a EFS multi file attach system that is attached, you would see like what is the number of the threshold, or is it a provisioned one, or is it an IOPS based? So those sort of measurements are done with it using this signal called matrix, and they detect, or they help you to basically ironclad or make your system more optimized, in order to help that you are not over provisioning, or you are not under provisioning your system. Moving on to the second signal, and that's quite renowned in the IT world, and that's logs. And that helps us, that has been helping us from the starting days of when we had those systems. And that's to help and that contains like helping a big solutions to a small solutions. It gives you overall, it can be a verbose logs where it churns out like a line by line details of what the method does, or it can be error based logs, so that it only spins out some data when there is an error, and the whole thing only capitulates on the fact that it basically helps you to diagnose if what a particular system does, or even what a particular function does. Or you can actually, if you are not clever enough, you can actually put it to in between 2 lines, that you can understand like, okay, what this line does as well. So this is one of the signals, and there are like loads of tools that is supporting both of these signals. Like CloudWatch helps for detecting matrix. Splunk is one of the SaaS tools. In logs, you can have similar CloudWatch setups, or as you have Kibanas, and there are multiple systems right now present around the world, and every day there are tools coming up to support or help you diagnose these things. Coming to the third system, and this is pretty new in the whole realm, and that's called traces. And this traces started coming up when the world of IT started shifting from the monolithic applications to the microservices-based applications, where the handshake of contracts, or I would say where the API calls started getting prominence while talking with other systems. So what this traces does is, like, the more better optimized your traces are in a multi API based, microservice based ecosystems, that helps you diagnose a problem and overall improves the observability of your whole of the ecosystem or the landscape that that your solutions are built in. And there are and also on the SaaS side, you have tools like Zipkin, and I know in other systems like Datadog, New Relic, you also have this feature where you can upload the traces and it comes up there. And coming to the AWS world, you also have AWS X-rays. And at some point of this presentation, I'll showcase to you how this whole traces works. And I can assure you it's really interesting one that you will see here, like how implementing a small code snippet into your application or making a reusable component, you can create a stacked trace which gives you a whole lot of insights into multiple API calls. Finally, this whole three signals is something that gets consolidated, and the term observability is born. And on the left side, on the right side of my screen, you can see a demo image basically from the Datadog panel. And this is just a demo example where you can see a single pane of glass showcasing multiple metrics from different systems. It can be one account, it can be 100 accounts, it can be one region, or it can be 100 regions, but it showcases metrics, it showcases traces, and it showcases logs. And it goes without saying that these data are pretty important for not only one factor of improving your systems, but it also gives value-driven business stream ideas. It gives you much more road of developments. It opens up multiple factors in a large-scale enterprise systems. Now moving on to the next point. How do you see the benefits are? So benefits, as I mentioned, like you get a much more clarity of the systems, because you can not only see what the logs that we have been that is showing up, you can create some autonomous systems or some automated life cycle rules based on the data that you get. You can make sure that your systems are self-healing. You can make this whole system deployed in a totally different region based on where the users target pool is based out of. And there are multiple things that you can do. You can ensure, you can check up a particular request you can using AWS traces X-ray and measuring the traces signal. You can see, like, okay, let's say one of the system has a latency while fetching some data. You can improve and optimize those things, like maybe decouple it with the SNS or some message broker. So these are sort of trade-offs that basically comes up the more you improve the observability of a system. And what are the values that as I mentioned, that goes through? The first and foremost that goes without saying is the cost, because eventually reading those data, acting upon this observability data, you make sure that your system is optimized as is, and it should behave as it should is. So that's one of the main factors that are the value that gets driven out of this Opentelemetry of the observability. Now coming to another term, because all I have been saying is pretty much similar to what we have been hearing till now, is monitoring. Because when you monitor a system, you get those details. When you set up these pager notifications, you constantly monitor those logs that are coming across. But as you could see from the picture, monitoring is just an upper part of the system. That is how you forcibly, or you customize your system that how it should be built. Whereas observability is much more it has much more in-depth layers, or it has the capability of shipping out huge amount of data that are hidden under the systems. So that's how this whole picture depicts. So monitoring is just like the higher level or the visual level of an iceberg that we have been tapping around till now. And observability has a capability to avoid disasters like Titanic, because that gives you insights of how much systems or what are the things that is underneath it. So once you make your system more ironclad, once you make your systems more observability improved, you can be ensured about your system. You can harden your systems. You can make it more optimized. Now, coming to some of the differences that we have been that we are trying to highlight or showcase here, as it goes without saying, like monitoring is something that is like when my system is green, everything is okay. When it goes red, then we start reacting on it, and that's called monitoring. Whereas observability is like, okay, what is my system doing? How good is the call between two APIs? Or what is the CPU? Is my system under it? The compute system, is it underutilized or is it overutilized? Do I see my auto scaling groups constantly being scaled up or scaled down? So it tells you overall like how my system is doing. Monitoring, as I mentioned before, like when it goes red, then the whole system or the monitoring system kicks in. And the observability is something like it tells you like why had the monitoring system kicks in. So I would say till now monitoring is just a set, and when you look at the bigger set, observability is the mother set, and monitoring is I would say the subset of that. And again, monitoring is much more reactive in setup. So what it does is like when there is like, let's say 100 error codes, and when the system starts misbehaving, then you start reacting on it. Then you deploy a reconnaissance team, then you do some SLAs, then you do some remediations on top of it. Whereas observability is like proactive in nature. So you guardrail that with multiple managed services. You make sure that when something is wrong, your blast radius of the impact is as lower as it can, and as isolated as it can from the bigger systems or the other impacting factors. So if there is something wrong, you tend to cascade. You don't tend to cascade those systems, and that's like proactive in nature. So you build the systems that it's self-aware, or that self-heals in nature. So there are multiple tools to do that, and for example, in AWS, in microservices, you can have something called circuit breakers, so that when you are starting some calls, when you see those calls starts failing, you stop calling those, but your system behaves as it is. So you have some fallback system to call, or some static data that to send through. So these sort of trade-offs that we need to do in the observability. And till now, I know many companies or many customers have already started doing that. But the reason for me highlighting or showing this thing or telling you these things is to make ourselves aware that, okay, in which concepts or in which umbrellas this sort of activities or this sort of implementation falls under. The last part of the difference is like it basically, as I mentioned, like it isolates the duration. It creates some smaller radius. It makes sure that your whole system doesn't goes down when you have a system that is more that has these signals of observability taken care and tackled across. Perfect. And now I guess we are all aware, and we have quite a clear idea of what we have been working across and what the SREs of our team has been telling about. And I'm pretty much sure you can, these topics are something which you will relate every day, and you touch upon some of those signals into your day-to-day life. Now, moving on to Opentelemetry, and one of the main topic for today, or how did it came into the picture, because it's really interesting journey that Opentelemetry had till now. And to give a little bit of background on that, I would say it first started with something called Open Census, because back in 2009 or 2010, when the world started seeing that multiple systems or multiple SaaS companies started coming up with their own signal detection system, or I would say the observability systems of ingesting multiple data or ingesting just signals, each of the companies has their own concepts or the constructs of doing so. For example, New Relic had their own way. Prometheus and Grafana had its own way. New Relic had its own way. Datadog had its own way. XYZ, blah, blah, blah. So what happened was like the whole developer communities started coming together, and there was like 2 open source projects that started that was incepted. So one was called Open Sensors, and that tackled the first 2 signals that I showcased was like metrics and traces. And then there was something called Open Tracing. And as you could see, the logs are still not there because as of now, there is no logs. The logs is one of the signals that is still present or still running in Opentelemetry. And I would say, like, I think it's 3 years ago or 4 years ago, the whole head of both these communities, like Open Sensors and Open Tracing, came together, and they felt that we are all building things towards a co-committed cause. So why not merge this whole both of these projects together and start a single project? And that's how Opentelemetry was born. And to give you a little bit of statistics on how this project is one of the hot cake in the current industry, and based on the last statistics that was raised by Gartner, you could basically see, like, after Kubernetes open source, Kubernetes in the open source Git check-ins or PR reviews, Opentelemetry comes up as the second one. So I would say it's a pretty much active, I would say, developer signals that are going on, or developer traffics are going on. Day to day, developers from the community are building or improving these signals or shipping out those data. And as it goes without saying, the third signals, the logs, is still not present. So that is also one of the things that is coming up. So in pretty much in few days, the logs will also come up, and then you could see this Opentelemetry concept or the constructs starts picking up pace and gets adopted into the developer realm. And even though I say it's still it will start to picking up pace, but as of now, I have been working with many customers who have already started investigating how to use this Opentelemetry within their applications, how to re-architect their microservices to adopt these things. And I will show you a little bit of that at some point of time in this demo, that it's pretty easy to use that because it's built on open source framework, and it's like agnostic of any SDK that you would use. Perfect. Now moving on to the advantages. So why did we move, or why did we choose to adopt the Opentelemetry, or what are the advantages? The first thing that goes without saying is it's a single way to capture data. Because initially, as you could see in the screen, like each of the language, each of the SaaS platform has their own way of collecting the metrics, collecting the tracing, collecting logs data. They had different sidecars, and they had different dependencies, and you had to basically pile up those SDKs, pile up those dependencies into your configuration file. So for example, if you are using Java, you need to constantly add or upgrade those SDKs through your Gradle or Maven. Or if you're using pip, you have to constantly upgrade this. Similarly, for TypeScript as well, you need to make sure that your package.json contains the latest library. So you had to keep your own track of updating those SDKs to consume or to ensure that there is no breakage within the systems to ship out those data. But what Opentelemetry did was, like, they took away all those needs. So whatever platform it is, whatever sort of language it is, there will be only one singular way of shipping out those data or instrumenting or re-architecting your code. So that's one of the big advantage, that it gave you a single way to capture data. So you don't need to tailor make your code snippets based on the SDK or based on the platform that you chose to visualize your metrics or signals.
So Aritra,
yeah,
this would be like having a standardized way to put, okay, we're going to put metrics, logs, and traces in a sort of standard format so we can all agree and be agnostic no matter which tool are you using. Is
Exactly.
that right?
Exactly. So it became much more easier, and the second, and from the business point of view, what it's a win-win situation for them, because let's say they choose they have been using X tool, but at some point of time they saw that a tool called Y came up with much more new features.
Mhm.
And with the existing world before the Opentelemetry, what would to adopt those features with Y system, what they had to do was to revamp their whole solutions to imbibe the SDKs of the Y system. But with this Opentelemetry, what it did was they took away that pain point of changing your SaaS vendors. And I'll showcase to you at some point in the later part of this demo, that you will see like how the whole systems are agnostic of this platform, and you have a standard framework within Opentelemetry to do the same activity that you can do, and without imbibing or without adopting any particular SaaS vendors SDKs.
Right.
Now moving on to the second part of the second advantage, was it gave you a much more data control. So like example is in different systems, what happens is, like, for example, I remember when I used some tools like Zipkin or some tracing tools, you need to have configuration files. Whereas I saw like some other systems have been using some other tool. So what we had to do was, like, when trying to call those APIs, we had to customize our request headers, or we had to customize our tokens and authorizations and everything. So I would say in the realm of microservices or multi-systems API driven setup, all those systems, we had to do those customizations in order to ensure that the data control was or I would say the shipping of data were proper and there was no breakage. But with this Opentelemetry, what it did was, like, as you can see on the left of the screen, it gave you a single YAML file. And in that single YAML file, you can customize your data. You can you can make sure your whole Opentelemetry is behaving as you want. And you can have something, and these are some of in the hotel collectors, or in the right side of the screen, you can see some of the terminologies like processors and receivers. The next slide will explain what those means, but in this slide you can actually see that it gave you a single source of truth to control all these data, and you don't have to keep on adding or keep on maintaining multiple configuration setup or something like that. So from one single file, you can do the whole setup, or you can basically tweak the Opentelemetry system. You can ship out those data. You can change how the data gets shipped out. For example, if you want it in batch, if you can do that. If you want to customize or filter out some of the metrics that shouldn't be shared, so those things could be done through one single file. And that's also one of the advantage, because you don't need to maintain this setup multiple places, or you don't worry about getting redundant or outdated configurations in multiple systems. And coming to this, one more thing that I would like to highlight here, that you will see that in the AWS world, how do we achieve this same feature. And now coming to the third advantage, as I said, like, this whole Opentelemetry project was built on open standards. So whatever you see in the current world, like the HTTP methods, the verbs, the codes around it, it's able to recognize those, it's able to tackle or adopt those things. Similarly, for the compute systems or the cloud systems, it basically captures all the metadata. For example, I have customers who have deployed, or who have started adopting this into Kubernetes systems. So in the Kubernetes systems, it starts shipping out all the pod related data and all the other data or within the application itself. Some of my customers, or or in this case that I'll show you, that they have deployed it into ECS, or the Elastic Container Services in AWS, and there they ship out those relevant details of how the systems or how the workloads are deployed as well. So in the current world, what it has done is it has taken all the open standards that are present and adopted them into their framework. So it's pretty open-ended, and it's pretty much easier to do that. And again, it goes without saying that it made the whole realm of designing observability agnostic of any platform. So now there cannot be any SaaS platform that tells that, okay, you should adopt this. Or if you or customers who have chosen to go with this Opentelemetry, they have seen a huge advantage of switching their vendors of SaaS to showcase the observability data or the signals within that. Perfect. Now moving to the components that, if you remember, I was showing 3 slides ago on the right side of my presentation, that what are some of the components. And in the next couple of slides, I'll try to basically showcase that. So what happens is, like, again, since this is a concept that goes inside your code, so I would say, even though the framework is agnostic of any of any SaaS platform, but you need to heavily re-architect or have the adoption of the Opentelemetry within your application. So for example, in Java, you need to have those Opentelemetry jars through Gradle, which I'll show. Similarly, in Python also, you have to have those through the requirements file. In Node.js or in TypeScript, you have to have those through package.json. So what you do is, like, you have to instrument your code, then you have to have some processors and samplings, and the last thing is some of the converters. So you need to make sure that even though whatever sort of a logs that is generated, maybe it can be log4j from a Java application, it can be simple console.log from TypeScript application, or it can print from Python applications. So you need to convert that into Opentelemetry format, and that is fully done on the application side, and I'll show it to you how it's done. But these are some of the components that are primarily done by the application developers to make sure that their application is Opentelemetry compliant. Then you have the collector agent, or the data aggregation and the filtering agent, and that is the XML file that I showcased, or the configuration of the single source of truth. So that is where you mention that if your data will be shipped out in an aggregated way, or if it would be a single data, single shipping out. And that's mainly tackling the cost factor, because this whole thing ships out those data. So what we have seen is, like, even though this telemetric offering, it's open source, it's a free world, but there are some cost that gets while in the data transfer charges, because they had these Opentelemetry formats, or this application, they ship out those data. And what you need to do is you need to do a trade-off of aggregating those data in batches, or for example, you can filter out, like, what sort of metrics that will be shipped out. So that is what is taken care by the collector agent. And the last part of that is the monitoring backend. And this goes without saying that the monitoring backend is nothing but the platform that you showcase. In my demo, I'll show it to you via AWS CloudWatch, but that's pretty much prevalent for any other tool like Datadog or New Relic or Prometheus or Grafana or whatever. So monitoring backend is just the tool that you share the data or the signals to. And the whole configuration is again done through the collector agent. So so in this slide, what you can see is, like, your application gets totally agnostic of the monitoring backend that it is. It's only what it does is instruments the Opentelemetry. It converts those signals into the Opentelemetry formats, and then the collector agent basically takes care of how the data will be shipped, and that's it. And so this is how the Opentelemetry component is present in the right now, in the current state, in the current world. And customers, this is how all of the customers try to adopt this within their platform. Finally, We will move to some of the demo parts. And what I will do is like, I'll showcase to you like how this is done in the Java code, but for the Python and the TypeScript developers, this is pretty much similar. The idea for me showing is just to highlight that how it's agnostic, or how it's how it is I mean how it is agnostic of any SaaS platform, or how easy it is just to adopt it. So I'll be showing a small visual code, and this is like a Spring Boot application that you can see, and it's running on ECS cluster, and I'll of course go back and show it to you how it's hosted. But coming to the Opentelemetry world, what we have to do is like just initialize this bin. And here, and what we have done is like we have added this Opentelemetry via build.gradle file, and the jar is adopted into our platform, and we have initialized this. And the reason, and for the Java developers, as you know, like in a Spring Boot applications, whatever is written within this main class, it gets initialized when the application starts loading, or when the application spawns up into the environment and it's run. And then on the controller side, it's just like an API that I'll show it to you how it is done. So in this REST controller, what we do is like we create some tracer from the same library that we have initialized, and then we write the file name, then we initialize some matrix, the first signal, and then in that matrix we give it a name. And here in my example, we have just assigned some random values that you can see. It's just some random values that gets shipped out. But again, in a real life scenarios, you can create many more things. You can ship out some more metrics and everything. And this is a custom metric that is being shipped out. But apart from that, when I'll show it to you in the dashboard, you will see like out of the box, this Opentelemetry ships out so many data. But just to showcase to you the snippet, this is how the whole thing is run, and this is how easy it is just to initialize those and call those within the methods to generate some random matrix. Now, for the interest of our time, I have hosted all the things in cloud, but it goes without saying that I'll share all the real links to you after this meeting, all the GitHub repositories that I have present for this. So just reach out to me if you have any more questions on this topic. Now, coming to the AWS part, so this is basically hosted as an ECS service, and I'll showcase to you how the whole solution construct works as well. But this is how you can see, like if I turn it to probably number, I think you can actually see it much better. I think I have a number. So this is, yeah, exactly. So this is how you can see, like you have some of the Opentelemetry utilizations. You can have some JVM, and these are shipped out of the box for you. So you don't need to, you basically don't need to configure those, or you don't need to externally or have some additional configuration shipped out. So once you adopt those jars, you can basically see all those things. But again, going back to the slide, your collector agent can be helpful for you to do the customization of what sort of matrix that you need to filter out. And coming to the custom matrix that I showcased here, this one, so you can actually see it. Let's say I'll do some ClickOps thingy here. So you can see this one also coming up in the slide. So here you can see, if I show you a number, it gives you a number here as well. So this is how, and this is the request API that gets hit, and you can see like this thing after some time will get changed. But this is normally how the whole custom metrics, and you can add some more metrics, and you can send some more meaningful data, because here I'm just sending a random int value, and that's how easy it is to set up. Perfect. So this is how the whole Opentelemetry works. Now moving to my next topic, or how whole AWS has adopted this OpenTelemetry design patterns. The first pattern is called ECS sidecar pattern. And in this slide, you can see it's pretty obvious that what you have to do is like you have to have an a.collector agent. And again, that is something which AWS also has out of the box given to you. And that's like pretty much updated. So AWS keeps on updating that. So what you have to basically do is like you have to deploy this AWS sidecar agent as part of your main payloads, and then you would start shipping out, or you would start seeing the same data into multiple monitoring backend. For example, you can see it in Grafana, you can see it in Prometheus, you can see it in Datadog, New Relic, and anything. But the challenge of this is like once you have multiple services and once you have multiple tasks inside those services, it becomes a little bit difficult for you to maintain or keep those things isolated. So you would end up basically managing those data or ensuring that each of them falls under particular namespace and everything. And the more number of services there are, or the more number of tasks there are, it becomes pretty much difficult to have a proper logical isolations or maintaining them in a much more meaningful way. And that's why the next thing, or I would say a more useful thing that have been started adopted by the customer is the ECS service pattern. And what you do here is basically you isolate your whole service, you isolate your configuration backend or the collector backend in a third-party service. And you can see from the screen is like you have a hotel service within a cluster, and it can be a multi-account, it can be a multiple region. But what you do is like you isolate your service, Opentelemetry, and you have all those configurations as set up here. And then what you do is like you mention what sort of a backend that it will go to. It will go to CloudWatch, X-Ray, or it will go to Grafana, it will go to Datadog or whatever. So what you just create a single standalone service containing the configuration. And the reason for registering that using a cloud map is to make sure that the service is recognized via multiple third-party services. And AWS Cloud Map is nothing but you can think of it as a service discovery. So what happens is like this service, let's say this service goes down. So whenever a new service comes up, it might have a different IP address. But using Cloud Map, what the purpose is solves is like the third-party services consuming this OpenTelemetry service doesn't need to know what sort of an IP that is has. So it can just refer it via logical name and then start shipping out those data. And now what I will do is like I'll go to the AWS console and to showcase to you how that is done. So this is my task definition of the Opentelemetry service that is present here. And as you can see here, when I open up my container, it only has one service. It doesn't have any payload. It doesn't have anything. And what it has is like, it has the open AWS configuration from where it uses or where it consumes the configuration data. And I've seen, and it's pretty evident that it's the same parameter. And if you remember, in some of my slides, in one of my slides before that, we will store this in a particular single stack and in a reusable component. And what we have done is like we have created a parameter store like this, and we have stored this here. So via this whole thing, or this whole parameter store, you control your collector agents. You mention which matrices that it will go through, or what sort of a logging level, what is the tracing tool that I am using, if I'm using a Prometheus endpoint, and if I'm using a Datadog endpoint. And the advantage of this is like, if you see, it falls under the exporter thing. So let's say tomorrow I have some more different tool called a New Relic or something like that. So what I have to do is like, without changing any part of the application, keeping everything as it is, I'll just update this whole parameter store and I'll just restart those containers. So what will happen? It will just add those and it will start shipping out those data as it is. And as I said before, what it does is like it basically the cloud, we register this service in the namespace called hotel service local. And as you can see, it's like it has a service called hotel service. And there we have registered this IP address. And that's it. So what it does is like tomorrow, let's say if I manually shut down this, a new task comes up, it get auto registered here. So this is how the first setup of this is done. So you bring out all your configuration or the collection or the monitoring backend related data via parameters. You add them into the Opentelemetry, and you start and you register that here in order to ensure that all the services that are consuming this Opentelemetry is able to recognize those. And the second part is the most important part, how this is consumed. So what it does is basically it calls this it calls this cloud map, this hotel service via the cloud map, and I'll show it to you in some minute. And these services are again agnostic of any configuration agents. It just has the application part that I have showcased like here. It's the same configuration here, so it only instruments your instruments your code with the Opentelemetry data, but it becomes agnostic of any configuration at all. It just have a endpoint containing this Opentelemetry register target cloud map logical namespace, and keeps on shipping those data there. So what you do here, so what advantage that you gain from here? First of all, you make your application ECS services decoupled as much as you can. You don't have to maintain any configuration agent or any configuration related data that were present in the sidecar pattern, because here you just have your ECS namespace and you just have an endpoint to ship out those data. And then on the monitoring backend side, you consolidate them into on your own. And here is one of the example that I'll show you how that is done. So I have created one of the service here, and here you can see in one of the Fargate service that I'll showcase to you how that is done. What we have done is we have created, or we have shared what will be the hotel endpoint where it will ship out those data. And this is the same thing as it is. So this is nothing but my AWS Cloud Map service name. So we are just mentioning the hotel cloud map service name with the code for port for shipping those data, and creating some logical isolations to ensure that this is being recognized here. So it contains a service name, it contains a service namespace. So what will happen is like when it starts shipping those data, it will contain these metadata for the monitoring backend to consolidate and capture on its own. And that's how easy it is. And again, I'll show it to you on the dashboards. And in my example, I have used AWS CloudWatch, but it's pretty much similar for whatever other services that you use. And you can basically see here, it starts shipping out all those data on the same format. And yeah, that is how the whole AWS Opentelemetry construct works. And and it's pretty easy, and it's just agnostic. So your services becomes agnostic of any SaaS tools. It just adopts those open source framework of Opentelemetry and starts shipping out those data. And yeah, that's how the whole demo that I have showcased to you here. I just repeat it here again, that you can search any metrics, but you will see that it basically ships out the data in the same format, and it gives you a whole lot of data, like what's the JVM count, what is the response size, what are the JVM parameters and everything. And yeah, if you create a module out of it, probably you can actually create a library out of it. You can have some similar sort of data across multiple metrics generated across multiple services. So what the recommendations or what we have done is like we have created a library out of that in Java. You can do the same thing. You can make a customized npm package in telemetry in TypeScript or in Python as well. You can have your own library and just call that within the multiple services. Then it will make your life much more easier. So just by invoking that, you will get a whole lot of observability data, whole lot of data within these three signals to make sure that your systems get much more business insights or I would say technical insights to improve and optimize your system. Now
Hey,
coming
look,
to yeah,
yeah,
sorry.
sorry, Aritra. I won't say that. Yeah, it looks, I mean, pretty nice to have a scalable telemetry in this case, Opentelemetry. But yeah, just to, instead of having to customize each application, so you have everything one place standardized, you create your controller, you customize your metrics, and then you can put it not only in AWS, as you say, in X-Ray, you can put it in other platforms without worrying what I have as a backend. So really, really helpful, I think.
Thank you, Dan. And the thing is, what we have seen here that adopting this, it's really beneficial from the initial stage of any application development that you do. So the recommendation from me would be start investigating how you can create those or how you can adopt these libraries into your application in the early days of your development. Because at some point of time in whatever project, in whatever solutions that you have, you need to have a trade-offs, because there is no one particular foolproof SaaS platform or the monitoring backend in the world right now we have that tackles all your problems in observability.
Yeah.
You need to have a mix and match. You need to do a trade-off, and Opentelemetry has been a forerunner while tackling the situations where reducing your pain points for choosing what sort of a SaaS platform, or for example, making your code less cluttered by adopting these SDKs and making it much more configurable, or have a single source of truth of shipping out those data.
Yeah.
Now moving to the last part of my demo, I just wanted to showcase to you, because tracing is one of the important signals that is present here. And I have been really beneficial while using this one. So this goes without saying that any case of microservices talking to multiple APIs or talking to multiple third-party systems, tracing is really, really important for everybody to adopt, because it gives you a huge amount of benefits of when you try to understand what is a latency, or if you try to reduce your call LTTR or call to request, or whatever parameters that you want to adopt into. And AWS X-Ray is one sort of a managed solution that is present right now here. But again, you can actually have in any other tool that you want. You can have something called Zipkin. You can have even other tools as well, just to adopt tracing. But to emphasize on this fact that tracing is ground zero for whatever microservices based development that you do. And it's pretty easy, I would say, in the AWS world, because AWS X-Ray is one of the pretty useful tool. And I have been using that, I would say, for 6 years right now. And AWS has done a great job of heavily revamping these services, bringing out with new features, making it lightweight, spreading these systems into AWS Lambdas as well. So without further ado, just to highlight what we do here. So the first thing is similar to the journey that we do for Opentelemetry, or is just to instrument your AWS SDK. And then there are similar to collector agents that we have in Opentelemetry. We have some sampling rules and invocation settings as well. So will it capture all the APIs, or will it capture some of the particular endpoints of the APIs? How will it ship data? Will it ship the tracing in a batch, or will it be one-to-one shipment of the data? And lastly, since this is a AWS specific service, you also need to ensure like you have proper roles and permissions for the ECS services, because at the end of the day, like without proper roles and permissions, you would end up those tracing would not reflect into your system. So just to highlight that keeping proper guardrails and adding proper permissions is also important while hosting those services. And what you do here is pretty much same thing like the ones that the only thing that is different here is like you don't have a jar like Opentelemetry, but in the same folder or in the same file, you can actually have a static code. And for all the Java developers out there, they know like static code is something that basically runs when at the first point of the application initialization. And this sort of similar journey can be made for Python and TypeScript as well. And in this static code, you initialize your AWS X-Ray SDK, you load your sampling JSON rules, and that's it. And then in all the files or in all the applications, you just add annotation. And I'll go back to my code once again. So this is how you see. So in Java, you just have this something called AWS X-Ray enabled, and that's it. So it will capture all your traces. It will basically give you all those metadata that you want to ship out and everything. And going back to my second point is how do you visualize that this is just an example, and I'll show you a real life demo in a few minutes. But yes, coming to the right hand side of this, you can see like it comes up with metadatas. It comes up with what is, if there is any error or not, what is the time that has taken. And since it's a managed service, it has a very, very good capability of identifying if there is any internal calls that you are making into any AWS services. For example, it's here you can see like from the left hand side of the diagram that it calls a DynamoDB table. It puts some data into S3. It again goes to the remote metadata just to make sure like I have proper roles and permissions or not. So it gives you a pretty good insight of what are the calls that is made and what is the time taken, or if there is any error or not. And now coming to an example that I would like to showcase to you here. So I have built an application which is again hosted as into an ECS container, which basically calls a DynamoDB, basically puts some random byte 64 data into an S3 and puts the ID into the DynamoDB table. And it's a pretty basic setup. So it has a NAT gateway and the load balancer in the public subnet, and it has the private IP. And what I have is like just like an API endpoint of the load balancer that I will try to invoke, and you will see like how it cascades across multiple systems and give out pretty good amount of tracing data. Now, just to make it a little bit more interesting, what I have done is like I have added some third-party calls as well. So it calls us a third-party web server here. It does a DynamoDB update. It does a Postgres solution here. And to highlight that how it also tackles out the exception here, this Postgres schema, I have deleted that. And in the demo or in the tracing that you will see that it also highlights that what is the error that happens. For example, that since this schema doesn't exist, it will give you an insight of that as well. So as I mentioned, while starting up this content of the topic, that it gives you a traceability, it gives you quite a good amount of insights into multiple microservices-based distributed system. You could see that here as well. So based on this whole construct, I have already spun up the data, and yeah, let me see. And this is my load balancer endpoint. So what I will do is like I'll basically execute it once. And what I will do by the time it gets executed, I'll go to my X-ray services, and inside this you will find all those traces. So since I already know my URL from here, I will try to filter my URL based on this. So you can see like it has already filtered out. So my tracing data from those endpoint APIs have already shipped into AWS. Now since I have hit it once, you can see here, it has already generated a trace around it. So it was just a few minutes ago, or a few seconds ago, it gave me a 200 because I made sure like it didn't fail, or there is like proper guardrail around it. But again, there is like a proper let me reduce my screen a little bit. So it's, yeah, I'll try to reduce my screen. Yeah.
Yeah,
So
you do
now,
it like that. Yeah.
so now you can see like it gives you a huge visibility. So from the API, it calls a front end API, and then in the front end API, it calls another API like this one, and then it goes to the third party client. So I'm just calling my company's endpoint, and it gives you a data. And then again, I call my AWS S3 and to put some data. And then based on that, I put that thing into S3. So these sort of configurations, and you can see it's pretty much concatenated. So you can have a parent ID, and then it's a segment and everything. And you can change it. You can find out like what is the time that has taken, for example. And if you go down, you can see like what are the response time, or what are the durations that is taken. For example, I have a put object here. So it has taken a little bit of time because it has put the object into the S3 bucket. Then I have a batch write. I just wrote those things. So these sort of terminologies that you can use. And as I mentioned, like I have deliberately deleted my the Dynamo Postgres SQL details. So here it has shown that it couldn't find my details. So it couldn't find my secret manager secret. So these sort of things, or these sort of trade-offs that you can, or insights that you can show visualize while using while adopting X-ray. So this is pretty useful in a distributed microservices REST architecture, and big systems and big microservices enterprise systems, when they have thousands of services, this is pretty useful, I would say. All right, so this was the demo that I had. And the last part is the AWS Lambdas. And Lambdas is much more easier. So you don't even need to do all those things as well. So it's just a toggle thing that you need to enable. So there is, in the Lambdas, there is something called tracing configuration. And if you basically enable that and have proper roles, you can see a similar thing like that. So you can see like the Lambdas calling another Lambdas, and then all the context and everything. So if there is a situation, even though this is not a recommended one, I would say that, or the recommendation is always to have a message broker in within, or there shouldn't be any case like where a Lambda calls another Lambdas. But let's say if there is anything that you have to call a Lambda, you also can enable tracing there, and that can give you a better insight as well. Like if one of the Lambdas are failing, or if you see one of the Lambda is taking a little bit more time. So you can also have these sort of trade-offs. And last, I remember that they have also enabled SQS as well. So in the fan-out architecture, where you have SNS and SQS adopted inside while calling a Lambda to Queen Lambda, if you have, let's say, SQS as a message broker, you can also concatenate or stack up those services as well. So similar to this thing, you can also find out in Lambdas as well. And that's, I would say, pretty neat in terms of AWS and traceability. All right, so as I showcased to you before, so this is how the whole dashboard looks like, but this is built on AWS, and Opentelemetry gives you the luxury of building it in anything like Datadog or any other tool. And the last part of this is like the telemetry cost and usages. And this is just to showcase to you like what are the costs that you must and that you can expect when you start building a system. However, I tried to make it on a much more higher side, but this can be reduced a lot, because as you can see from the assumptions that you are running a system which has like 1,000 requests per minute, and it's capturing all of them. And then also you only have like just like $250 per month. And normally what we do is like we don't capture all of them. So no, we only probably capture when we make some third-party calls, or when we have some important calls, or when we expect that some calls might pass through or fail through. And on the CloudWatch side, and this is just to highlight the metrics and logs, but you can actually change it to some other things, some other SaaS tools, but then again, it will vary. But on the AWS side, when you have like a huge amount of ingestion, and this is also not pretty common because you don't store 1 GB of log volume per day. And if there is somebody out there storing one GB of log volume per day, I'm pretty much sure that there is something wrong. And then we need to go back and understand the observability and only ship out the relevant logs. But still, let's say if you have 20 custom metrics and 1 GB of log, you would just end up paying like $75 per month after the free tier usage. So all in all, it's like pretty good deal. I would say you would have a systems, you would have observability turned on your systems. You would get more insights just paying like close to $300 per month. And I would say it's a win-win situation, and that drives a good amount of value. And we have seen that in the customer landscapes, that it has improved the systems quite a lot. And I also have some of the customers right now working with that, they have started adopting this Opentelemetry and using these features of AWS. All right, so this brings to my end of my presentation. Thank you for listening to this. And if you have any questions, just shoot out, and I'll share all the links that I have built across and shared across at the end of this demo. And you can find that within the description of my link as well.
Yeah, as you say, we will share all the links for all of your resources, your blog, on all that you want to share. You will be in YouTube in the description. This video will be uploaded more or less within this week, but anything else, you can write any comments and I will just forward them to Aritra in the YouTube video. So Aritra, thank you so much. I think for anyone who wasn't able to join, can just watch the YouTube video and see, okay, he has done that. Maybe I have some issues or some doubts, maybe he can reach to you. I will just post the links that you share with me, and also your contact in Twitter, just if they want to reach you.
Yeah, perfect. All right. And I'll share all the relevant details with you then.
Okay. So thank you so much for being here. Thank you to if you're watching this, and thank you for being in vBrownBag. Goodbye.
Thank you.